Oh, good evening, my friends. Let's continue to solve this problem. As we mentioned in last video, we get the equivalent circuit and the line current in the stator for our 4-pole induction motor. Okay, in the question B, it gives us this condition about the mechanical losses, which is 870 watts. So it means it's the power of P, because we know in the power science we have three different of power. S equals P plus JQ. S is apparent power, P is the active power, and Q is the reactive power. So the unit for S is VA, the unit for P is watts, the unit for Q is VAR. All right, that's a background knowledge. So we also get the slip as previous value, which is 5%. Okay. So the first one is asking us to calculate the synchronous speed and the mechanical speed. So these are two different names for the same thing. What are the same things? The synchronous speed means the speed for the stator. All right. And the mechanical speed means the speed of the rotor. All right. We know for a inductance motor, the speed of the stator comes from the voltage, the AC voltage. So we can calculate the synchronous speed like this, because we know the frequency for the power source is 60 Hertz, which means in 1 single second, it will have 6 revolutions. And we also get the pole number as 4, which is the pole pair is 2, right? Is 2. So we can directly get the speed of the synchronous speed for the stator, which is ns equals 60 times f divided by p divided by 2. All right. So it's 60 times 60 divided by 2, which is 180 RPM. RPM means revolution per minute. So why shall we divide the pole pair number? That's because, if we only have one pole pair, one revolution means it will turn the whole cycle, 2 pi or 360-degree. However, if we have two poles or three pole pairs or two pole pairs, it doesn't need to revolve the whole cycle. If we have two pole pairs, it only need to revolve half of the circle. It will generate output, the whole cycle output. So we need to divide it, the pole pair number. So that's the NS. And we know the definition for the S or slip number, which is NS subtract NR divided by NS. So the speed of NR equals 1 subtract S times NS, which 0.95 times 180, and the final result is we can use the calculator to do the calculation, right? So which is 1710 RPM. Okay. However, the question asks us to convert the unit from RPM to radians per second. That's quite easy. Okay. Because the NS is 180 RPM. All right. And we know it means in 1 minute, it will revolve 180 revolutions or circles. Each circle, it will run 2 pi, okay? And divided by 30 because 1 minute contains 30 seconds. The result is 188.5 read per second. That's the value of ns. So similarly, we can get the value for the nr, which is 179.07 read per second. Okay, that's for the first question. And for the second question, I think this picture will give us a better view. It's like this. Okay. All right. Now we can have a better view. So this is the air gap. Okay, this is the air gap power, which means that's the whole power that our stator imports to the rotor part. That is the air gap power. At the left side of the air gap power is the power for the stator, and which comes from the power source. Okay, so the power is expressed like this. This is a line voltage. Sorry, this is a phase voltage. Oh, forgive me. This is a line voltage times line current. Yeah, and the times square root 3. Yeah. Okay, we don't care this part currently because we are focusing on the right side. On the right side is the entire power that transferred to the rotor part. And first of all, we use P air gap times 1 subtract S, which is P conversion. It has another name is PEM, which is electromagnetic power. And the other part, which is P air gap times S, the slip number, is PRCL. It has another name is CO consumption power. The CO means copper. It is due to the resistance for the coils in the rotor. You know the coil in the rotor is made of copper. It has, although it's very small, but it has some resistance. So this power means I-Fun square R. All right. And the entire power that convert into the mechanical power is P air gap times 1 subtract S. So this part of power subtract the other, the other losses, such as the friction or something else, and the finally is the output power. Okay, that's the basic idea. So let's get back to our question. All right. So first of all, we need to calculate the air gap power. We know the S equals the value of S equals V times I. However, the real value of S equals V times conjugate of the current, but that's another story. Okay. So presently, we need to get the voltage and the current that applied on the rotor, which is Z2. Okay, so what is Z2? That's a semi-equivalent circuit in the previous question, right? This is Z1, which is R1 JX1. This is Z2 equals R2 plus X2J, and this is JXM, right? Recall the previous question. If you don't know it, look at my previous video. All right, so let's solve this thing, these three parameters. All right, so we know in our equivalent circuit, the Z2 and the XM, they have the relationship of parallel. So we can get the parallel value, yeah, as Z2 at JXM and the Z2 times JXM. And finally, we can get the voltage that applied on Z2 or Z parallel. Sorry, it should be like this. It equals the total phase voltage subtract the voltage applied on the Z1, right? Yeah, that's quite straightforward because the Z parallel has a relationship with the Z1 of series, right? Series. This is the VP. Okay, so the VP is quite straightforward, which is 400 divided by square root of 3, which is 230.94. So what is the value of VZ1? So we get the entire current in the circuit in the previous question, which is I1. Okay, I1 equals 3.99, and the angle is minus 27.67. Okay, so the V parallel equals VP subtract I1 times Z1, which is 239.94, subtract 30.99 with this angle times R1 plus JX1, which is 0.45 plus 0.9J. So the calculation is, boring and difficult. I don't do it here. I believe you can finish the calculation in your spare time. I just write the final result here, which is 201.44, and the angle is 5.06 degree. The unit is watts. All right, now we have the voltage. Now we will calculate the current, which is V parallel divided by Z2, okay, which is 2.644506 divided by 7.1 plus 0.9 J. So be careful, this is 7.1. 7.1 equals what? Tell me. It equals the x2 divided by s, all right? Divided by s, which 3.355 divided by 0.05, okay? Yeah, that's how we get the value of 7.1. And we can get the final result for the value of current 2, which is 28.845. The degree is 2.16 ampere. All right, now we have the value of V2, which is the V parallel, and we have the value of I2. So now we can get the entire power that applied to the rotor, which is the air gap power, which is the I2 square times R2 divided by S. Be careful, this is a three-phase circuit. We need to multiply the factor of 3, which is 28.845 square times 7.1 times 3, which is 17722.32 watts. That's the total value of air gap power, and this is only difficult one we have to calculate, because the else one, we can use the S number to get it. So the second, the EM power, which is power conversion, equals power air gap times 1 subtract S. So which is 17722.32 times 1 subtract 0.05, which is 16836.2 watts. Okay, that's a power of the EM power or conversion power. And finally, the output power equals PEM subtract P losses, which is 16836 point subtract 860. This one is given in our question. So the final answer is 15966.2. Yeah, that's our answer. Watts. All right, that's for the second question. The third one, the efficiency. Efficiency of power means what? Means the output power divided by input power. So we get the value of output power. So the only thing for us to solve is to get the input power. Input power is quite straightforward. P equals what? V times I, right? Yeah, V times I cosine theta. Okay, so we get the I expression I1, which is 30.99 with this angle. Okay, we already get it in the first question. And we already get the phase voltage, which is 400 divided by square root of 3 volts. So the input power is straightforward, which is 3, because it's a 3-phase circuit. So 3 times VL times IL, L means line. Here, P equals 3 V phase times I phase times cosine theta equals square root 3 VL IL times cosine theta. So here I just wrote the wrong thing. I will rewrite it like this. It's a phase current times phase voltage times cosine theta. Yeah, this is the power factor, right? So now we can get the final result, which is 400 this thing times 399, yeah, times cosine 27.67 is 0.886. So the final result is 19008.9 watts. Okay, so currently the efficiency is straightforward, right? Which is 1596.2 divided by 19008.9, which is 83.99%. Okay, so the questions in our power is not that difficult. So the only physical bottom is just what? Just the Ohm's law. Ohm's law. Yeah, we just need to convert our mind from the real space, only resistor, to a complex space, which is Z equals R plus GX. All right. Okay, now the final question is asking us to calculate the torque, the induced torque and the load torque. Okay, the induced torque means what? First of all, P equals tau times omega. Okay, that's for our rotation system. Yeah. The induced torque means the torque to generate air gap power. And the angular frequency is the frequency for the stator. All right. So P air gap equals tau times omega stator. Now tau is straightforward because we already get the number of air gap power. We already get the number of stator angular frequency, which is 17722.32 divided by 188.5, which is 9402 Newton meter. All right, this is for our induced torque, and the load torque is straightforward. It is used to generate the output power. Output power equals the load torque times rotor angular frequency. So the tau equals P out divided by omega r, which is 1596.21 divided by 179.07, which is 89.16 Newton meter. All right, that's all the solution for the part B. Hope you enjoyed. Thank you. See you soon. Bye bye.